the discriminant. So, first we'll bring ourselves back to what the quadratic formula is, which is x equals minus b plus or minus square root b squared minus 4ac divided by 2a. And now, this part of this is very important in quadratics, and to explain why, I'll just give you 3 different parabolas. And it honestly doesn't really matter where the y-axis is, it just matters where the x-axis is for this exercise. Here, we can see that the graph does not cross the x-axis. Here, graph touches x-axis once, and here the graph crosses x-axis twice. And so, for a moment, maybe think about how with this quadratic formula we could get these 3 different results. What in this here would tell us? And I can tell you that it will be the square root part, the part under the square root. The discriminant, and I think the symbol for it is a delta, which is a triangle, is equal to b squared minus 4ac. Now, why? Why? Because think, and what about, well, not just why, but what about the discriminant could give you these 3 different scenarios? And it's all to do with this plus or minus, for example. Say you got a b squared minus 4ac equals 16. So now you'd have, your 2 solutions would be minus b plus 4 over 2a and x equals minus b minus 4 over 2a. 2 separate things. And you keep doing that, but if this were to instead equal 0, then plus 0 and minus 0 is the same thing. So no matter whether you do the plus or minus, you'll get the same answer. And that's this case here. Repeated, which is called a repeated root. 1 repeated root. So that's why I say if the discriminant equals 0, there is 1 repeated root. Because it's no matter whether you do the plus or minus in the quadratic formula, it gives you the same answer. And if it is greater than 0, then there are 2 distinct roots. And now, the other case is if it's a negative. And you can't get a real number from a negative number. Like, the square root of, like, if x squared equals 1, x equals 1 or x equals minus 1, right? You can't get from either of those numbers a negative 1 by squaring it. And you can, of course, get complex numbers, but at AS level, you don't worry about those. But the thing we can say is if the discriminant is less than 0, there are no real roots. So that's what the discriminant can be used for. If you calculate the discriminant, you can use it to find number of solutions. And this could be for any equation. For example, it could be something like and it says find number of intersections. And what you would do is you would rearrange and then you would calculate discriminant. So then that would be b squared 4 times a times c, and so that's 4 plus 96, which is 100. So it will have, and then this, well, what we would say is this is greater than 0, therefore 2 points of intersection. If the discriminant equaled 0, then you would say the line is tangent to the curve. And if it was less than 0, you'd say they do not meet. The other use of the discriminant, it's not really a use, it's just something that could be helpful, is seeing if it is factorizable. And a quadratic will be factorizable if discriminant is a perfect square, i.e. if you square root discriminant, you get a rational number. Then the quadratic is factorizable. A lot of this using the discriminant to find number of solutions comes up a lot in coordinate geometry. So we will cover that later on. But essentially, what you want to remember is if the discriminant, which is the thing under the square root, b squared minus 4ac, if it is less than 0, then there are no real roots. The graph will not cross the x-axis. If it is equal to 0, the vertex will touch the x-axis. So there will be one repeated root. And if it is greater than 0, it will have 2 distinct roots.